The super fog in New Orleans, the debilitating atmospheric rivers in California, crippling dust storms in Illinois, flooding, lightning fatalities, rapidly intensifying hurricanes. What if we could prepare ahead of time for all of them? What if we knew that each was coming and could evacuate and prepare days in advance? Artificial intelligence is all around us. Social media, banking, facial recognition, digital assistants, but that's not all. Scientists right here in North Alabama are using artificial intelligence to make destructive weather a little less destructive. I'm Way 31 morning meteorologist Grace Anello. I sat down with some of the leading research and data scientists in the country to learn about their contributions to the machine learning field and how advances being made there could change weather forecasting and emergency preparedness as we know it.
We have collected weather data for centuries, right? Can we learn from that vast amount of data and do a data-driven approach to doing weather forecasting?
Machine learning is a great tool. It's one of the ones that's evolving the most, and we are continually developing new products here in the Earth Science branch to help with anything from flooding to wildfires to even if we've got dust impacting travel on the roads. If we can identify the dust from an AI point of view and help someone who's got to close roads or limit travel, that might help save lives as well.
Dr. Manil Maskey and Dr. Christopher Schultz work at NASA's Marshall Space Flight Center in the Earth Sciences Division. They're leading the charge not only on research and development of new artificial intelligence tools, but also on the execution of those tools in real-world events, on research, development, and execution of AI tools.
Here at Marshall, I lead a team of data scientists that are working towards making the science research lifecycle much more efficient using data science techniques.
Dr. Maskey explained to me that many still think of artificial intelligence as a stranger in the sky, so to speak. We know it's there, we know it's working, but we don't know how or why. Dr. Maskey says that isn't the case in the meteorological field at all. He and his team are using centuries of climatology data to change the scientific method as we know it. Scientists usually create a hypothesis and use large-scale and complex equations, and using a series of tests, each with different controlled variables, they determine whether or not their theory was correct. Dr. Maskey says, thanks to artificial intelligence networks,
you really don't have to have a hypothesis and do the science and prove your hypothesis, rather than you use the data to come up with the conclusions.
To forecast, meteorologists analyze the jet stream, upper-level wind movements, atmospheric moisture, energy, and more. To do so, a chain of lengthy equations must be used and solved over and over again. They're called nonlinear partial differential equations. They're essentially unsolvable, and they take into account assumptions such as friction, oceanic heat, and more.
So what it means now is doing good at things that you really can't program. A little bit of background on NASA science. We do missions, right? All of these missions are geared towards one thing: collecting data and converting that into knowledge.
How? They're creating something called advanced neural networks and foundation models that intake data, and instead of programming it into an algorithm, it stores it, learns from it, and becomes more accurate on impact and timing accuracy.
So we have lots of data now, we have advanced algorithms, and we have new ways to use supercomputing environments. Those are the three things that are changing the definitions of AI.
Dr. Christopher Schultz and his team are putting the neural networks to work.
One of the new things we're doing using machine learning is we're working on predicting lightning in the next 15 to 30 minutes.
Everything we know about lightning safety is reactive. Thunder roars, then go indoors. But moving indoors takes time. Schultz and his team are currently working on software that adds physics to their predictive models and would allow a warning time of 30 minutes prior to lightning striking in an area. This would allow event organizers and fans in the stands to be alerted long before the threat became imminent, giving them time to take proactive safety actions.
So disaster preparedness and recovery, right? Those are the ideal use cases for natural disaster.
Dr. Maskey's neural networks allow disaster relief teams to see real-time data showing where the effects of floods and fires is most potent. This allows for disaster relief agencies to have a plan of action long before boots are ever on the ground. But artificial intelligence isn't only creating an impact on a global scale. It's processing information to make a difference right here in Alabama.
And that's the thing is, even though we do have a controlled river in the Tennessee River, there's a lot of other rivers like the Paint Rock that flood regularly, and there's people that are affected, and bridges and travel ways. And so that's kind of the vision here. So we can give you another day or two ahead of time. People can plan ahead and move, and emergency management can plan ahead for those larger scale events.
And this is just the beginning. Doctors Schultz and Maskey tell me one day all forecasts will be made with help from machine learning. Whether it's long-range temperature forecasting, predicting tornado wind strength, or the likelihood of severe weather in any given system, Schultz tells me new neural networks will be able to intake infinitely more data, compute it faster, and spit out results ready for analysis from a local meteorologist in just a fraction of the time. Not designed to take away human forecasters and meteorologists,
Augmenting the process rather than automating.
but rather leaving those scientific minds free with more time devoted to making the critical decisions rather than crunching the numbers. Now just imagine a world like that.